Hey physics fans, today we're going to be talking about TP 8-38. In 8-38, we have a skier that at some initial position, his initial speed is 8 meters per second. We were asked to find his final speed. In the problem statement, it talks about how there's a force due to kinetic friction, about 80 newtons. It gives us the mass of the skier, his initial speed. This is all indicative of a conservation of energy problem. That's the physics we're going to use to solve this problem. Now, draw step. I draw my skier at his initial position. I draw my skier at his final position. Now, I know this is a conservation of energy problem. So what I'm going to do is set a reference point where the potential energy of the skier initially is equal to 0. And the potential energy of the skier at his final position due to gravity is equal to mgh. Now, they gave us the mass of the skier, the initial speed of the skier, the force due to kinetic friction, the height that the skier displaced, and the displacement from his initial position to his final position. We're going to assume that there's no air resistance. Now to the solve step. In the solve step, for conservation of energy problems, if you look in your course summary, you'll see that they have these energy tables and they explain explicitly how they're created. So, we already talked about how the potential energy of our skier initially is 0 because of our reference point, and the potential energy of our skier at his final position is equal to mgh. Now the skier system, the skier slope system, does not have a spring in it, and the skier is not rotating. Now, the skier did have initial speed, so I have to assume that he has some sort of kinetic energy. Finally, he has some kinetic energy because we're asked to find his final speed. I take both of these quantities, the initial quantity and the final quantities that are summed up in our conservation of energy table, I bring them down and I subtract my final minus my initial. I set it equal to 0 because there are no forces, there are no non-conservative forces doing work on our system. I solve for my final speed and I get 5 meters per second. In B, I do have work due to non-conservative forces. They told us it was 80 newtons. So now I have the force due to kinetic friction dotted with the displacement. And I also have that resolves when you do the dot product to FD cosine 180. Well, where do you get the 180 degrees? Well, the 180 degrees is from our picture. So when the skier displaces up the slope, the vector of that displacement is going up the slope. The vector for the force due to kinetic friction opposes that motion and goes in the opposite direction. So the angle in between the displacement and the force due to kinetic friction is 180 degrees. Now, everything else on the table is just like A. I bring all the stuff on our table down, and now I have to set that equal to the force due to kinetic friction dotted with the displacement times dotted with the displacement, and then that is equal to the force of kinetic friction times displacement times cosine 180 degrees. Now, I solve for my final velocity, final speed, and that's equal to 4 meters per second. And now we're going to do a quick check to see if this is right. The units make sense because we're talking about speeds. The units of speed is meters per second. Least amount of sig figs in this problem were 1. And let's check to see if it's reasonable. Well, if the skier was initially going 8 meters per second, and then he transitions up the slope, he's lost some of that kinetic energy. It is transferred into potential energy, then it should be less than 8 meters per second, and it is. Now, when you have non-conservative forces taking energy from your system, his final speed should be even less than 5, and it is at 4. That's it for TP 8-38. See you next time.
To the window, to the wall. All these problems solved. All these problems solved.